Welcome to Mimi's Math Channel. Graphing exponential functions, they have a pattern that I like to look for, and that's in my signs. If I have an exponent like y is equal to 3 raised to the x power, what I want to look for are the signs that are attached to my x and my y. For this one, both are positive. Maybe you won't get too confused by it, but say for instance, you have the exponent y is equal to 3 raised to the negative x power. What you need to do is look for your exponent's sign first, because that represents your x. The sign in front of the number represents your y. On your actual coordinate plane, you should look for where your x is negative and then your y is positive, because the x part of your exponent, the sign comes first. Don't put it in the order that you see the sign. Like in the third example, you see negative and then positive, but that would be incorrect because you have to have your x first. Your x is your exponent portion. So therefore the plus sign comes first. Once you figure the signs out, you can look at your coordinate plane, and for this second row, you see that I have a negative x and a positive y, which indicates that my graph is going to go towards quadrant 2. This is kind of what it would look like. It's telling you that, okay, it's going to start off kind of flat, and then it's just going to grow exponentially, or it's going to drop or decay exponentially. The next portion, you've seen something like this in my other graphing videos where there's transformations taking place. The only difference is it is exponential function. My f of x is still my y value, meaning that it may say y equals. The signs that are in front of my a tell me whether or not there's going to be a vertical reflection over the x-axis when I'm graphing. A is the number that tells me if there's going to be a vertical stretch or shrink. If I'm asked by what factor, it's whatever that number is. What's inside of your parentheses is your base. That base is raised to an exponent. The exponent has a second part to it, which is the h part. H tells you whether or not the graph is going to shift or translate to the left or to the right. If there is a sign in front of your x, then that's going to tell you whether or not there is a horizontal reflection over the y-axis. That's important to remember because this sign changes depending on what's going on with the x. If the x is positive, you're going to take the opposite sign of what's currently shown for h. If your x is negative, you will keep that sign. If you get confused, take the entire exponent, set it equal to 0, and whatever your x value ends up being, that's the sign that you will use. Your k includes the sign, and it tells you whether or not your graph is going to shift or translate up or down. If you want to know whether or not your graph is an exponential growth graph, then you want to look at the criteria shown here. Your a will be greater than 0, and b will be greater than 1. If you're looking at the table that you create or the table from your calculator, look at your x values. As x is increasing, your y's will also increase. If you're trying to find out if it's an exponential decay graph, typically your b will be between 0 and 1, and there's other things that come up that could affect that. And again, if you're looking at your table, as x is increasing, then your y's will be decreasing. Pay attention to how your graph is ending. Let's look at this problem. My x is positive and my y is negative. I look at that and I write that to the side and I go back to my notes. I know that where x is positive and y is negative, that's going to be quadrant 4, which means that my graph is going down. So let's just make sure that that is the case by actually working through the problem. After I do that, the second thing I do is I take my entire exponent. One case I set it to 0. In another case, I set it to 1. I'm going to solve for x for each of those, and whatever that x is, that's what's going to go in my table. The first one, it was -1. When I solve for x in the next one, I see that x becomes 0. If x didn't become 0, and let's say it was 2, then I would still use 0 because 0 is going to give me my y-intercept. I want to look for my horizontal asymptote, which I told you in another video. If you spell the word hey, that will remind you that your horizontal asymptote means y is equal to something. Well, what is y equal to? It's always whatever k is. It doesn't matter what the sign is. Take the entire k. So in this case, it's +2. Asymptote means that my graph cannot cross. You can get really close to it, but it can't cross it. Y equals 2 is going to have a dashed line, which indicates that horizontal asymptote. The y-axis is the one that's up and down, and this is where it's 2. I can plot my other points once I substitute that information in. I would take this -1, substitute substitute it in there. You can manually do it, or you can use the calculator, which is what I did. And then you do the same for the 0. So you're going to substitute it in twice. For the first one, I put a -1 in for x and I got the 0. For the second one, I put a 0 in and I got a -4. I would go ahead and plot that. Where x is -1, y is 0, and where x is 0, y is -4. The graph gets very, very close to your asymptote, but it cannot touch it. You can't really tell by my graph, but if you actually go to a calculator, first thing you want to do is go to Y, put the problem in. The second thing you want to do, if you just kind of want to see what the graph should look like, is just hit graph. And it's not going to show you your asymptote, so you're going to have to just manually know how to do that. And the second thing you want to do is go to second and then hit graph again. Above it, it tells you table, which is in blue. And you want to verify that your table is matching what the calculator says. So the calculator does say that x is -1 and y is 0. And when x is 0, y is -4. Domain will always, in exponential graphs, be all real numbers. That's -infinity to +infinity. Or sometimes you will see this symbol. That means all real numbers. Your range and end behavior can be determined if you know your horizontal asymptote and your domain. My range always goes from bottom to top. My graph starts at -infinity. It goes on forever and ever downward. But where does it stop? It has to stop at that horizontal asymptote. It doesn't touch it, but because we can't put a number that's really, really close to 2, we just put 2. If I know my horizontal asymptote, I know part of my range. And if I know my domain, I know part of my range. It's going to be one or the other. If I'm starting from the bottom, then it's going to be -infinity. If it's going towards the top, then it's going to be a +infinity, and then the number goes first. You only have so many options for your range. And then as far as my end behavior, as x is going towards -infinity, what's going on with this arrow? If I were to stretch it, it's going up, right? But it can only go up so far. It has to stop at 2. As x is approaching +infinity, what's going on with this arrow? If I stretched it out, well, it's stretching out towards -infinity. If I know my range, then I know my end behavior because it's going to be the same information. Intervals of increase or decrease. Take your finger and just trace the graph. Am I increasing or am I decreasing? And you always go from left to right. I'm decreasing. Intervals of increase or decrease is your domain. -infinity to +infinity. And let's just say you wanted to know what the transformations were. What I would look at is left to right. I have a negative sign in front of my number. That's a vertical reflection over the x-axis. If I forget all of this, I can just go over and look back at my notes. And if I am trying to figure out what this number represents, well, that's a vertical stretch by a factor of 2 because there's a number 2 there. If I'm trying to figure out, well, which way am I going, left or right? That's a horizontal translation left. Just take the exponent, x plus 1, set it equal to 0, solve for x. X is -1. Well, negative means that it's going left on the coordinate plane. And then finally, I have a +2 as my k. Well, that means I'm going to have a vertical shift up. I'm going up by 2. Or another word is translation. Do the usual, hit that thumbs up and subscribe.